message invalid pizza size. Inside the test cases, we had written defined the exception class with assertions dot assert throws. Okay, first parameter is the name of the exception class that is going to throw the exception. In our case, we had used the exception class itself, but we can also create our own exceptions, which is user defined exceptions, and we have to use that accordingly. So in that case, the name of the class will be that user defined class that we had created. Second parameter, we have used the lambda function where we are invoking the identify pizza cost method using the object of the solution class by passing a pizza size which is invalid. So in such case, it will throw an exception. So we are verifying whether the exception message that it has thrown is matching with this message or not. If it is matching, it is going to uh, if it is matching, the test cases will pass. If it is not matching, test cases will fail. Okay, so even if there is a difference in the case or a difference in the message which is being thrown, then the test cases will fail. So the main idea behind testing our exception is to check whether the correct exception is thrown or not by the code. Okay, so we do write test cases at the exception level also. So I'm sharing this code with you. You can save it. So this is the solution, and then I'm sharing the test cases. You name the package accordingly while creating the project in Eclipse. So next I have shared the test cases. Okay, so each test case should start with the annotation at test, because unit test framework understands test case method only when you annotate it with at test annotation. Otherwise, it treats those methods as normal methods only. Right. So this is what we had understood. Now, before I start Spring Boot, would you like to know the JDBC API, how the connection happens and how we interact with the database from the front end? Shall I discuss that? Or if you already know how we connect to a database from front end, I will proceed with the Spring Boot framework directly. Okay, I will treat that as no. So this is the course that we are going to discuss today, Spring 5 Basics with Spring Boot. And this is the link. This link was shared by Giriza also in the chat window, not chat window, in the invite mail that was shared. And I'm sharing the link again in the chat window. So this is the first entry-level course when we talk about the Spring Boot framework. And if you see the TOC of it, we'll start with what is Spring Framework with the introduction. What is inversion of control, which is popularly known as IOC, how dependency injection happens and what exactly dependency injection is, what is auto scanning, then we'll see introduction to Spring Boot. So before we proceed with Spring Boot, we will understand Spring Framework first, how it works. Spring Boot is a superset of Spring Framework. Spring Boot came recently in the market. Before Spring Boot, we were using Spring Framework, where we had to do a lot of manual configurations. And that configuration is like a boilerplate code that we used to write for every project that we are creating. With the release of Spring Boot framework, all those manual configurations that the developer used to do is eliminated now. Now developer focuses on writing the business logic of the application. Okay. So here we'll also understand what is auto wiring, how we auto wire the object of another class into an existing class, which we call it as a bean. We will understand how we log messages using Spring Boot framework. We'll also understand aspect-oriented programming. Aspect-oriented programming, like we have object-oriented programming, similarly we have aspect-oriented programming, where we separate the cross-cutting concerns of the application in a centralized location. When we say cross-cutting concerns are something which is commonly used across different business classes. Okay, it can be logging, okay, handling exceptions, okay, configuration. So all those details will be inside a single file. So we implement that using AOP. Okay, so this is what we are going to cover here. So this is going to be the coverage for next 2 days, including today. Okay, so the pre-content to this is Java programming fundamentals, Java language features. Along with that, what we discussed in last 3 days. So those are those two courses are the prerequisite for Spring Boot framework. So we need to first understand what exactly Spring framework is, and then we will proceed with the implementation later. So all the libraries or framework available in Java, they are mostly open source, including Spring framework. Okay, and Spring framework is basically used to develop web as well as enterprise applications. We design web applications as well as enterprise applications using Spring framework. And Spring framework makes the development really easy. Okay, writing test cases is also easy, and it makes code more reusable. The way we write code using Spring framework makes the code more reusable, and maintainability is not at all an issue when we create or design web application using Spring framework. So we there is in when we design a web application, there is a concern where we want to avoid tight coupling between the applications. Okay, so when we use Spring framework, okay, so Spring framework by default, it allows us to design an application in such a way that the applications, okay, or the files, or you can say the beans or the classes, they are loosely coupled. Okay, they are loosely coupled means there is no such dependency on the other application. So tight coupling means where one module cannot execute independently without the other module. Okay, loose coupling means there is no dependency on existing module for the other module, right? So we create it as loosely coupled application. So Spring framework helps us design loosely coupled applications where dependency is minimum. So these are some of the features of Spring framework. So Spring framework, first of all, it is a lightweight framework because in Spring framework, the jars that we are going to use, they are very small in size. Okay, it will be in single digits. Okay, MB, some MBs will be there. And Spring framework provides with the inbuilt deployment server, which is nothing but the Tomcat server. Okay, where we can easily execute. Okay, so there is one question: what is jar? Jar is Java archive. Okay, so it's an archive file. We have three types of archives. We have jar, war, and EAR. Jar is Java archive, war is web archives, and EAR is enterprise archives. So basically, these are packages, okay, which comprises of all the dependencies, okay, which is required to write an application. For example, to write JUnit test cases, we need the JUnit jar file. And yesterday, when we discussed about properties and logging, there also we had configured some jar files. So these jar files allows us to implement if you see common loggings 1.2.jar, this jar file allows us to implement the logging functionality of our application. Similarly, we have log4j and other jars available. So jar file is like how in your application to enable audio, in your application, you need to install audio drivers, right? So audio drivers helps enabling the audios, okay, so in your laptop or desktop. So they are just a driver. So here, similarly, we have jar files, which is a pre-packaged, you can say, bundle that helps us implement certain functionality in our application. For example, in order to log messages, we need these jar files. And if you expand this, you will see it comprises of org.apache.commons.login, and it has some inbuilt plugins, you can say, that helps us to implement those things. So all these are predefined by Java, and it is packaged into a single bundle, which we call it as jar. Okay, so that is your Java archive. Hope that is clear, Professor Ramesh. All right. Then another feature of Spring Framework is non-invasive. Okay, non-invasive means we don't have to implement or extend any predefined classes. Okay, and the application is completely designed using simple model classes. Okay, which we call it as POJOs. POJO is pure old Java objects. So pure old Java objects, we call it as POJOs. So basically, this is a class which comprises of private attributes and public getters and setter methods. So we call that as POJOs. Okay, so they are non-invasive in nature. That means it is not dependent on any other classes. Okay, it because we have the inbuilt jars available, so that makes the Spring framework non-invasive. It's not dependent on any classes that we need to implement or extend. Okay, and it is loosely coupled. So loosely coupled means one file, one .java file is not entirely dependent on another .java file for the execution. Okay, and they are not tied. They are not tightly coupled with each other. Okay, they are loosely coupled. So we have certain features in Spring Framework that makes it loosely coupled, like dependency injection and aspect-oriented programming. So in aspect-oriented programming, what we do is we identify the cross-cutting concerns of the application like logging, exceptions, and so on, and we keep them separate from the core business logic. Okay, so we don't make it dependent to specific classes. We keep it separate. We keep it separate from the core business logic. That's how it makes our application loosely coupled. Means there is no tight dependency or tight coupling between the core business logic and the cross-cutting concerns like your logging functionality, exceptions, or uh, any other error handling that we do or configuration in our application. So they are not bind with any other core business logic. Then we have inversion of control, which we call it as IOC. Okay, where we takes care of the life cycle of the object of our Spring application. Okay, and the dependencies are injected in pom.xml file. So dependencies could be like my application, I'm writing unit test cases. So my dependency is on JUnit jar files. I'm using servlet or some other application. There is a dependency on servlet API. Right, so those dependencies are kept centrally in pom.xml file. So we are injecting those dependencies to our application in the form of pom.xml file. And as and when the project gets loaded, it automatically takes care of downloading the updated dependency and keeping it centrally inside our Maven repository. So Maven actually is a build tool. Okay, Maven is a build tool. Like you might have heard about the Ant, which is the one of the oldest build tool. Okay, which is used to build an application, the final binary, if you want to derive it. So we use Ant in earlier days. Now we have build tools like Maven, we have Gradle, right, which is used to build our applications, and they have their own commands or goals using which it automates the entire build process. So Maven has a central repository. Okay, there is a central Maven repository also that actually keeps all the dependencies in the remote location. So you can see we have logging frameworks, we have Java specifications, JSON libraries, core utilities, mocking web assets, logging bridges, HTTP clients. For all this, there are dependencies which are kept at the central Maven repository. Now, when we write dependencies in pom.xml file, we don't have any pom.xml file here. We will use it today. So those dependencies are stored in our local repository. And the local repository is by default created inside C drive, okay, users, the username who is using the machine, and .m2. So this .m2 folder gets created whenever a Maven project is created, and whenever it downloads any dependencies from the central repository, those dependencies will be kept inside repository folder. So if you see, all these are the dependencies that is available here. Like if you see, we have JUnit dependencies. Depending on what all versions of JUnits you have used, all those will be kept here. And the application will automatically, the Maven project will automatically takes those dependencies from this location. It will not download it again and again. So we don't have to explicitly configure these dependencies again and again. This is just a one-time activity. And if the first, it will look for those dependencies under this repository folder. If it exists, it uses those dependencies from this location. Otherwise, it downloads and keep it here. Okay, these are the dependencies for MySQL. Okay, so this is the Maven's central repository, local repository. Local repository is something which is kept locally in my machine. Then Spring Framework also provides with a Spring container. Okay, so this Spring container actually is a loosely coupled, you can say, box or container where it takes care of all the life cycle, entire life cycle of a Spring application, starting from the creation of an object, initializing the Spring Bean, and managing all the dependencies that is required in our application. So Spring Container takes care of all those. Like we have Tomcat container. Similarly, Spring provides with a container which is called Spring Container, where it takes care of the entire life cycle of a Spring Bean. We'll understand what is Spring Bean. Then, as we discussed, aspect-oriented programming is another important feature of Spring Framework, where it separates all the cross-cutting concerns like logging, any transaction management, security related from the core business application. Okay, we need not define it in with the core business logic. We must keep it separate, okay, in a different .java file, and it will be used centrally by all the business classes. So these are the features of Spring Framework. So let us understand more about Spring Framework. So right now, the latest version of Spring Framework is 6.x. Okay, 6.x is the latest version. At the time when the course was designed, that time the version was 5.x. So this is that's why it is written as 5.x here. Any Spring Framework version can be used. Should be 4.0 or more. Okay. So these are the four important modules which are provided by the Spring Framework. One is your core container. Okay, all the important feature or the basic features which is provided by the Spring Framework is maintained and managed by the core container. Okay, then we have data access or data integration module. This module takes care of the entire uh, persistence logic of an application, where we connect with the database, store data in our database. So this module also takes care of retrieving the data from the database or any kind of update that we want to do with the database. Okay, and it uses object relational model technique to implement the persistence logic. So which is object relational model, which is also popularly known as ORM. Okay, ORM. So what exactly object relational model is? See, if when you see the front end application, our Java or Spring framework, in Java, we do implement aggregation, right, between two classes. We implement has a relationship and we call it as aggregation. But if you see the database, any database, there is no way we implement aggregation there. Okay, so what data persistence layer of Spring Framework does is it stores those uh, data in our front end application in the form of app objects and map it accordingly across the table. So which we call it as entity relational model. Okay, ER model also. So object relational model is that. So it instead of storing the data directly, it stores the data in the form of object in the database by mapping it to the appropriate table. So all the conversions from object to database table and database table to object is taken care by data access module. Okay, that also we'll understand in the next course. Next course. I think third course. This is the first course where we are understanding Spring Framework. Next course will be service layer, where we'll understand the service layer of an application. I think we'll start service layer from this module only. Yeah, from this module. Next will be we'll understanding the rest persistence layer, where we'll understand how we are going to persist or store or connect with, our Spring application with the database. Then third important module of Spring Framework is web. Okay, so all the operations related to web application development, okay, all the activities related to the web application development is taken care by web module. So we do have different dependencies for it. And this is how we define a dependency. Let me show you one example. We use the tag here. For example, suppose I want to define the dependencies for web module. This is how it is defined. So first we define group ID. org.springframework.boot. And then we define the artifact ID for it. And we can define version also. So this is Spring Boot Starter Web. So this is the dependency. This is how the dependencies are defined, and where it is defined, we'll understand it later. And third tag could be the version, where we define the version of this particular web module. So when we define these dependencies, there is no other configuration required in our application. Okay, we don't have to do any other configuration. This dependency, once defined, will take care of all the activities that we do with respect to web application development. And then we have few other core modules, which is for testing the Spring applications. So this is the architecture. Okay, so you have the service layer, you have the core container, and core, beans, context, expression, aspects, AOP, all these are part of your core container. Then we have web layer, we have data access layer. So if you have a look at the core container, so it is divided into multiple sections. You have core container, you have web layer and data access. Let us have a look at the core container first. So core container is the base for all other layers of the Spring framework. For all other layers like web layer, data access layer, for all other layers, this core container, which comprises of the six modules, this is the base for all other modules of the Spring framework, and they are completely dependent on this core layer of Spring framework. So we have something called beans here. Beans are nothing but this is a Java class which we define it as a Spring Bean, and it provides the basic container for the Spring framework. Then we have context. Okay, this also provides a container. This also provides a container for application context. Application context actually is a feature which is used to create and manage the Spring Beans. All these things we'll understand in the form of code also. How do we create an application context and how it manages the Spring Bean and how we make use of those Spring Bean to access different layers of the web application. Then you have expression layer here. Okay, expression module. This is to in wherever there is a requirement where we want to manipulate the object or we want to fetch any object, for all those purpose this expression module is used. Okay, expression module will be used for all the uh, manipulation that we do with the objects or any kind of fetch operation that we do with the object, that is done using the expression module. We have AOP here. AOP basically takes care of the cross-cutting, separating the cross-cutting concerns from the core business logic. Then coming to the data access layer, that comprises of JDBC, okay, ORM and transactions. See if there are any questions. Difference, Professor Sudharani asks, difference between context and aspect. So aspect basically is used to separate the cross-cutting concerns from the core business logic. Cross-cutting concern means anything where we are anything that does logging of an application, handling exceptions, okay, taking care, handling and managing applications, any kind of transaction and security that we are performing. We separate such logic. Instead of writing such logic with the business logic, we isolate them and write it in a different module, inside a different package. So that is aspect. We have annotations for it. We have dependencies for it that helps us writing those modules. Then context is something different. Context is a Spring container, okay, which allows us to create a Spring Bean. Okay, a context is a Spring container, which allows us to create a Spring Bean, using which we access different layers of an application. So what is Spring Bean and all that we will discuss, because you need to see the code, how a bean is created, what is the annotation that we use to create a bean, and how we access different layers of an application using that Spring Bean. Okay. All right. So that was core container. Then you have data access layer, where you see the JDBC, ORM, and transactions. So JDBC module of data access layer helps us to uh, connect with the relational databases, right? So we use this module to connect with the relational databases. So all the classes, interfaces, or any other dependencies that are required, okay, to connect to the database is provided under JDBC module of data access layer. It is pretty much clear what the JDBC does. Then ORM is object relational mapping, not module, object relational mapping. So what ORM does is, this is a popular framework, you can say, ORM framework, that actually map our application object into the underlying databases. So you might be aware of popular ORM frameworks like Hibernate. You might have heard about Hibernate. It's a very old framework that is in place in Java, and it is being used from a very long time. So we have Hibernate, which is a popular object relational mapping solutions. Okay. And then we have JPA also, Java Persistence API. So we are going to use Java Persistence API. Okay. And somewhere we'll use Hibernate also to do the object relational mapping. So object relational mapping means the Java objects, we are going to convert it to the underlying database tables, where the class name, okay, the class name will become the name of the table, will map with the name of the table, and the attributes of the class will be mapped with the columns of the table. Okay, so it does that mapping. So writing or querying database becomes very easy when we use ORM, uh, object relational mapping uh, module of data access layer. So Hibernate and Java Persistence API, or JPA, they are popular solutions for object relational mapping. Then we have transactions under data access layer. So all the activity related to the transactions is provided by the transactions API. Okay, so transaction API is basically used in the repository layer. Okay, so we have three layers when we talk about. We have a client layer from where the call gets initiated. Then we have a web layer where we write our service or business logic. Then we have repository layer. So this layer actually takes care of communicating with the database. So this comprises of all the APIs that is required to establish connection with the database by making use of Hibernate and Java Persistence API. So we'll discuss these in detail. Then the third module of Spring Framework is web layer. Okay. So this layer provides all the support for web application development. So all the support that is needed for web application development is provided by web layer, and this web layer itself provide us the support for model, view, and controller architecture, which is popularly known as MVC. MVC, model, view, and controller architecture. Model is a class that comprises of private attributes and public getters and setters. View is the presentation layer, which is the front end of the application. Controller is a layer that acts as a router and the controller takes care of communicating or passing the control or data to different layers of the web application. So we popularly call it as MVC architecture. So we have web MVC. Okay, so web, in this web layer, we have web and web MVC. So difference is web MVC is the actual layer which takes care of providing the model view controller pattern, okay, which is very useful to design a server-side application. And this web MVC also provides support to implement RESTful web services. RESTful web services. Okay, so that also we will discuss it going forward in our course. So we make use of web MVC for that. So web layer basically is a container that is that has access to the application context. Okay, and this has all the features that is used to develop any web application. And web MVC basically takes care of the model view controller architecture and provides support for the RESTful web services. Webflux is another important part of web layer that provides support for reactive programming. Okay, so this Webflux is a popular framework. Like you might have heard about Flask framework in Python, Flask framework. So that Flask framework is for web application development. Okay, similar to that, we have Webflux also, which is a part of web layer. It provides an additional support to create a reactive programming in Spring Web application. And WebSocket provides communication between the client and server. And the communication that WebSocket provides is a two-way communication, means client to server and server to client. So we have WebSocket layer for that. Okay, then finally we have this test layer. Okay, so all the testing that we do, that we perform in all the testing that we perform in Spring framework is provided by the test framework. So all the support that is required, okay, to test the Spring application using TestNG or JUnit is provided by this test layer. So these were the important modules of Spring framework. And if you see, this is the history of all the revisions. So it's initiated from Spring 1.0 in 2004. So it was the first stable version with initial features, then Spring 2.0, where JPA, AspectJ support and XML support was available, released in 2006. Then the annotations came in with Spring 2.5 that was released in 2007. And then we have expression language and support for REST API came with Spring 3.0, and 3.1 has support for Java-based configuration also, because earlier version of Spring framework had support for only XML, only for XMLs. Okay, but 3.1 onwards, it has provided support for Java-based configuration. Means using Java code, we can do the configuration as well. Otherwise, all the configuration earlier were done in XML only. Then 4.x and then 5.x. Now we have Spring 6.x also. So Spring 5.x, make sure that you're using JDK 8 plus. At least JDK 8 or more. If it is JDK less than JDK 8, certain features will not work. So we need a minimum of JDK 8 to use Spring 5.x. Any queries here? Any questions? So let us move forward. So here we understood what is Spring Framework, why we need Spring and different modules of Spring Framework. Okay, so the first thing that we are going to understand in a Spring Framework is inversion of control, which is also known as IOC. So we'll understand what exactly IOC is. So as you see here, earlier, it was the responsibility of the developer to create the dependent application object using the new operator in the application. So while doing that, if there is any change required in the application dependency, okay, the code change, okay, any change in the application dependency requires code change, and this result in more complexity as the application grows bigger, because the bigger the application, okay, you need to locate more areas for uh, making change in your code, because if you are changing any dependencies for your application, you have to do the changes in all the locations in your application. And if it is a huge application, it becomes quite tedious and complex to do those changes. And if in while doing so, if you misses out on any of the location, the application will not work. So the solution to this was IOC. Okay, the problem was the developer was manually doing all the configurations. Okay, all the configurations, initial configurations. Later, if there is a need to change the configurations for your project, then you need to change the configuration in all the locations of your project, and carefully you have to do it. So while doing so, there might be a chance that you might miss out on certain files, okay, which you have not changed. So this will cost the entire application, and your application may not work. And then developer spends a lot of time debugging the code and identifying the issues in the application. And it becomes quite tedious and complex, okay, to resolve all such issues. So to eliminate all this, IOC feature of Spring Framework came into picture, which is used to design a loosely coupled application. Because prior to this, the application was tightly coupled. If you change a dependency in one file, you need to do the corresponding change in other file also, because they were tightly coupled. Okay, but in with the introduction of inversion of control, it made the Spring Framework loosely coupled. Okay, and what IOC is? IOC is inversion of the responsibility of the application's object creation, initialization, and destruction from the application to the third party as a framework. Okay, instead of, for example, uh, if we take our example of Infosys, so we do have food courts at Infosys. Similarly, in college also there are some vendors, right? So college or any company does not personally manage those vendors, right? They give the contract to third party. So who takes care of the all the activities, starting from the purchase, preparation, service, everything. Okay, so the company or the college has no role to play there. Okay, so they provide the entire contract to a third party. So that way they can focus only on the business. Company can focus only on the business. So they will not deviate from the IT business the uh, to the you can say hotel business, right? It will switch to that. So that's way that, because employees are there in lakhs and thousands and lakhs employees are there, they will eat their breakfast or tea, coffee, then lunch, okay, snacks. So where they will go? So as a company, they have to provide these facilities for their employees. Similarly, if the number of employees grows, they need to make sure that There are hospitals inside the campus. So we have hospitals also. Then there are two or three banks available where you can do all the transactions that you can do outside. There is a post office inside. Okay, gym facility is there, dormitory is there. So all those facilities are available. So these are given to the third party so that the company can focus on the core business logic. Similarly, inversion of control, uh, which is which helps you to design a loosely coupled application. How it helps the design loosely coupled application? It helps uh, by giving the dependencies responsibility of the creation of objects, initialization, destruction of the object, or managing the entire life cycle of the object to a third party. And that third party is your Maven dependency that we use here, okay, in the form of pom.xml file, so that the developer can focus only on writing the core business logic. So the third party that takes care of it will take care of the entire application lifecycle management and configuration of the application. So this to implement this IOC, okay, there is a way. It is implemented using dependency injection. Okay, so next we'll understand what dependency injection is. So dependency injection is so your Spring IOC. Spring IOC means inversion of control, where we are giving the responsibility of the entire life cycle management of object to a third party, and this is done using dependency injection. So in dependency injection, we do not create objects, right? So object is not created manually by the developer. Instead of doing that, the third party injects our dependencies in our project, okay, which actually takes care of how the object will be created, how it will be managed, and how it will be destroyed once the life cycle is over. So this is again dependency injection you can think of as a design pattern. And this actually helps us designing a loosely coupled application, which is completely reusable, and the testing also is easier. So that's the important feature of dependency injection, which is helping us create a loosely coupled application. So the benefit of loosely coupled application is writing unit test cases becomes easier. The code becomes reusable. Okay. And yes, it is loosely coupled. And it also helps us in keeping the configuration logic separate or isolated from the core business logic. So that if any configurations changes are required, we have to do those changes only in one location. And while doing that, we don't have to recompile the code, because whatever configuration changes we do will be automatically detected by all other applications lifecycle, all the objects of the application. And we have to do the change only in one location. We don't have to do it in multiple location, because all those configuration logic is kept separate from the core business logic into a single file. And mocking also becomes easy. Mocking is a feature where we ignore the objects while testing. Okay, suppose I want to test the service layer. Okay, but service layer is connected to the persistence layer, right? So when we are testing the service layer, we need to mock or ignore the object of repository or the persistence layer. So that is called mocking. So we just test only that functionality that we want to test. We don't have to bother about the other dependent functionality of the application. So mocking also becomes easier using dependency injection. Am I audible now? Okay. Actually, there was a power cut here, so network issue from my side. All right. So we will focus on the core module now, and we'll understand what is Spring IOC and how we do the dependency injection. So we have a Pojo class, then Pojo class. The IOC container takes care of creating the Pojo class. All the configurations will also be taken care by IOC container in version of control, and using that, it creates object of the application. The object of the application is created using that. So all the application logic of the application logic will be provided by the Pojo classes. And Pojo is pure all Java objects. So this Pojo class is where we write the application logic. Okay, IOC container will take care of all the configuration metadata. All the configurations related activity will be taken care by IOC container. And IOC container will also takes care of creating any object of the application. And for that, it uses Pojo class to create the objects and pass it to the appropriate layer of the application. So it uses application context and Bean Factory uh, interface to create those objects. So we have two things now, Bean Factory and application context. Let us understand them. So Bean Factory is where all the beans are created. And what are beans? We had discussed in the previous slide. Spring container managed application objects are called beans in Spring. Okay, this is a small one-liner definition. Spring container managed application. Any objects that is managed by the Spring container, we call them as Spring beans. Otherwise, we call them as just objects. Whatever we were dealing with till yesterday, we call them as objects. Now, if those objects is being managed by the Spring container, in Spring, we call them as Spring beans. So Spring beans are nothing but the Java objects, but the difference is they are managed by the Spring container. So in Spring framework, we call them as Spring beans. So Bean Factory, okay, Bean Factory is the factory where all the beans are created, bean objects are created. So it uses Bean Factory class and it does not support any annotation, whereas applications support annotation based dependency injection. Bean Factory does not support enterprise services. So if you want to create an enterprise services, we need to go with application context interface only. Bean Factory supports lazy loading and application context supports eager loading. Lazy loading is something, see, in our laptop also, okay, there are certain applications which gets loaded immediately as soon as the OS is, our system is up, right? And there are some other applications which load little later, not immediately when the application starts. So we call it as lazy loading. So it gets loaded in the memory when all other basic support applications are getting loaded in the application. And we will see how the objects are created You can see a code snippet here, how we create objects using Bean Factory, how we create objects using application context. We will be using the application context way of creating the object. So we will be using this application context, okay, to configure the Spring Bean. So we'll understand that first. Okay, let us start with a demo. Let us understand with a demo where we will create the Maven project. So you'll learn how to create a Maven project and how we can configure it. So there are various tools available for Spring. We can continue using Eclipse. You can also use Spring Tool Suite, which is also known as STS. Spring Tool Suite is similar to Eclipse. It is just that this particular IDE is specifically designed for running and executing Spring projects. But it provides support for Java-based project also. So you have different versions here. If you want to use Spring Tool Suites, you can download it from here. So for Windows, you have 4.19.0. I will continue using Eclipse for it. Okay, I'll not be using this, but Spring Tool Suite, if you can make use of it. So first one is Spring Tool Suite for Visual Studio Code. So you should not go with this. You should go with Spring Tool Suite tools for Eclipse. Okay, so you can use this. So professors, if you have any queries, please let me know. Anything you want to ask. This section will be little challenging for you to explain to the students, because before you start explaining Spring Boot to them, Spring Framework to them, you have to do a lot of background with Java. So whatever we discussed in last 3 days, you have to go into much details of it, right? Because they may need time to understand if they have not gone through with. Few students are very bright, so they will explore these things all by themselves. But the majority of them, generally, they do not explore things. So it would be little challenging to explain all these things to them. You may have to use some bribe in the form of giving them what is the benefit learning the Spring Framework, how much popular it is in the market. You can talk about the jobs in this area and what is the market size. So that way we can gain initial interest. But That will not be for long because soon they might start losing interest in this because this is very intense thing, right? Okay, it is already 11:19. Okay, fine. We'll take a break then, no problem. You can download Spring Tool Suite, okay, but you explore it later, not during the session, because I don't want you to deviate from the discussions. Because if you are busy doing Spring Tool Suite, your focus will be diverted. So you can do it post lunch. As of now, you can just understand the entire flow. So we will take a break here. After the break, we will understand the Spring IOC. How do we create Spring Beans and how do we create a Maven project and how do we create a Spring application with the help of a demo. So we'll take a break for 20 minutes now. It's 11:20, so we'll be resuming in another 20 minutes. All right, so let us continue. Yes. So we understood Spring Framework and we understood different features, different modules of Spring Framework, different layers of Spring Framework also. And now it's time to understand with the help of an implementation. So this course contains all the details, okay, whatever I am discussing in the demo. You will find the demo here also under demo Spring IOC. You will find it all here. And this is how we will create the application context object. This application context object is created so that we can access the configuration class using the configuration class stored in the application. So whatever name of the class you are creating, you have to provide the name of the class here. And then using that application context object, we will invoke getBean method. And this is going to fetch me the name of the bean. So as we discussed, bean is nothing but a Java object which is managed by IOC container. Okay, Spring container or IOC container. There are two ways to access a bean. One is using the uh, bean name, using the bean ID. If you're using the bean ID, then we have to do the explicit type conversion. If you don't want to do explicit type conversion, then you have to use the exact name of the bean. Okay, you will understand shortly what exactly I mean by this explicit typecast and the bean name. So using Eclipse, I'm going to create a new Maven project. So while creating the new Maven, we will not choose or uncheck anything here. Okay, so we will just click on next. Artifact from the group org.apache.maven. And from here, we have to choose the archetype as Maven archetype quick start. So this is the template we are going to choose. Okay, whatever version it is showing. So we'll choose this. These steps are available in the course also. And with that, I will click on next. And then I will provide the group ID under which group you are going to create this Maven project. So you can give basically this group ID is the organization name. Like it can be Apache or it can be Oracle or any organization. So group ID is related to the organization. So here I will give as com.infi. Artifact ID will be the name of this catalog is nothing but a template that we are choosing to create a Maven project. So the template that we have chosen is for the web application, which is from the package org.apache.maven. So when I say template, it's like when you create a new PPT, you choose a template, right? The default template, depending on what kind of presentation you are going to create. Whether you are going to do a graphical representation or text-based, or there will be images, or you are creating a profile. Based on that, you choose the appropriate template. Similar to that, we choose the appropriate Maven template here. So we have chosen um, web start archetype quick start from org.apache.maven project. So in Maven terminology, we call it as a catalog. So with that, I will click on finish. This package name has to be renamed to something else. I'm showing you the steps again because I have missed one simple step. Go to Maven project and we'll use the default workspace location. So here it says create a simple project, skip archetype selection. We'll not skip it. We'll choose a particular archetype. So archetype basically refers to the, you can say a template or a toolkit. Okay, a toolkit which will have a specific pattern using which we are going to create a Maven project and write our application. So org dot apache dot maven and then archetype quick start. Click on next. com.inf is going to be the group ID, artifact ID. I will give it as demo Spring IOC. And this package name, I will remove this extra name, just com.inf. Group ID and package name will keep it same. Click on finish. So this creates a Maven project with source main Java folder and then source test Java folder. So the test cases will be written inside src test Java, all the test cases, and all the .java files, all the solution files related to the application will be created inside source main Java folder. All the Maven dependencies will be stored by default inside .m2 folder repository. And it has a pom.xml file, which is the configuration file for the Maven project. It holds all the dependencies. So if you see, it has got dependencies for JUnit, okay, only JUnit as of now. So this was the group ID that we had given, and this is the artifact ID with which the project is named. And version is 0.0.1.snapshot. Snapshot is initial version, which is under testing, okay, which is not yet stable. URL, you can provide your company's URL, which is optional in this case. So this step that I demonstrated, you will find it here under demo Spring IOC with the first page itself. How do we create a Maven project? Which archetype we are supposed to choose? This is slightly an older one. Whatever version it is shown in your project, you can choose that. And this is where we had provided all the details. And this is the pom.xml file. So we just need to copy the existing content of pom.xml file with this. I'll not copy, replace each and everything. What is new here, I will replace that. So compiler, Maven compiler, I will choose as 11. This also basically points at the Java version 11. Then what else I need? This particular tag is missing from the properties. You can copy paste everything. You can copy paste the entire code from here if you're finding it confusing. I'm copy pasting only those which is not available here. And then dependencies, I have only JUnit. I will need this Spring dependency also. org.spring framework context and spring.version. This Spring context is needed because we are going to create a Spring application context. Under dependencies tab, I need to paste this also. So we have two dependencies now. One is for the application context, and the group ID is org.spring framework, which is the official website of Spring Framework. This is the organization name. Artifact ID is Spring hyphen context. Okay, so and then the Spring version. So whatever the latest version is available or the stable version is available, it will get downloaded. So to download those dependencies, we need to save everything. The moment you save, you can see all those dependencies are added. JUnit 4.11. Okay. Those dependencies are also added. Now my JRE version is still showing 1.7, although I have updated it as 11. So to reflect that change, just we need to do a right click on the project, go to Maven and choose update project. Yes, professor, in STS also things are almost same. But the way we create Maven project is slightly different there. Rest everything is same, like providing the artifact ID, group ID, everything is same. So we'll click on update project and you have to choose the checkbox force update of snapshots and releases. Okay, so we'll press OK and you will see immediately the Java version has updated to 11. So how it has updated to 11? Because it reads the pom.xml file, whatever configuration we have provided under properties. Accordingly, the project details gets updated. So our Spring project is ready. We can start writing the code and creating the bean. Hope this much is clear. I have downloaded, but it is not shown apache.maven. It is slightly different there. You can, if you're using Spring STS, I think you can directly create a Maven project. You don't have to choose any artifact or any template there. Just remind me a little later. I will look into that STS also and will not do any XMLs. We will not create any other XML file. The only XML file that you will see is pom.xml. Other than that, any other configuration needed, we will do Java. We will use Java based configurations. No other XMLs we are going to use. So here I will add a new package along with the interface for service layer, and I will name it as com.infi.service. And this interface, I will choose it as customer service. So this interface will have a default method. We can create multiple. I will just add one method, and then inside the same package, I'm going to create the class that is going to implement this interface, and that I will name it as customer service IMPL. So this is going to implement customer service interface, and that interface provides with one default method for which I have to provide implementation here. If you remember the Capstone project, the structure was same. Capstone project that you did, there also we had an interface with some default methods, some abstract methods, and then there's a class that actually implements the interface. So that's why we name it as IMPL. That refers to the implementation. Okay, the class that implements an interface, and this is how we actually write the code. So we will not focus on the repository part here. We will just focus on the service layer alone. And let's say I'm just returning a message. Added successfully. It will return this message to the caller. Whoever calls this plus with the name Spring plus with the name Spring. This is where we are going to define it. And the configuration class in okay, should be generated with that configuration annotation from our context or annotation. And this class will be treated as the configuring class. We will be configuring our bean is nothing but the Java object, but it is managed by Spring IOC container. So let us create an object and return it here. And the object will be of customer service IMPL. Return new customer service IMPL. And this, so what we are doing here, we are creating an object of the customer service IMPL, and we will hand over this object to the Spring container by declaring it as bean. Okay, so now from any location, we will be able to access this particular bean. So this is identified as a Spring bean. Now one final class that we will create is the main method. Okay, so we will do it inside the class app.java, which is already provided. Okay, so here first I'm going to create the application context. So that is using abstract application context is equals to new annotation config application context. Yes, this one. So here in this particular object, we are going to provide the detail about our configuration class, which is Spring config dot class. So this is the class that we just created, Spring config class, which has the bean definition. We are providing details or link. We are linking to this particular class. Now I'm going to create the reference of service class, and this service class will connect with the bean by using context object dot get bean. So what is the name of that bean that we had created? This is customer service IMPL. So we need to do a typecasting, customer service IMPL. You can give your own name also. Okay, so in the bean tag, it has a property called name. So let's say I'm giving the name as customer service. So now I have to provide this name. If you explicitly provide your own bean name, then you have to use that. It is not going to access this directly now. So I have to say customer service. Okay, so that is also there. Okay, so using this, I will call the method of service class, which is add customer, and it is returning a value which is of type string that I can display to the console. And then we will close the context object. And we can run it as Java application. Cannot load configuration class. So now why it is not able to load? This looks fine. There is no problem here. Is there anything that we missed out here? Maven properties.
Sir, we need to add Spring Core and Spring
Which one?
Spring Beans. We need to add in the dependency injection in the dependency form.xml file.
Spring core is not required here because this Spring context is sufficient.
Okay.
Spring context is sufficient.
And Spring Bean as well, not required?
Not required because this context will take care of that bean also.
Okay, sir.
Let me do it other way. We have something called Spring Initializer. Because this pom.xml is little old in the course, I also suggest you to go with Spring Initializer. Here, this is a official website where we can create our Spring Boot application, okay, by providing few bare minimum details. So this is https start.spring.io. I am sharing this in the chat window also. So here, project I have to choose as Maven because we are creating a Maven project. So these are other build tools. You have Gradle, Groovy, Gradle, Kotlin. These are two flavors of Gradle. So project for build tool, we'll choose Maven. Language, we have to choose Java here. And these are the different Spring Boot versions available. Don't go with the latest version always because other dependencies may not work. Okay, so choose the dependency or the version. Choose the version which is somewhere in between and stable. Snapshot means this is the initial version 2.7.14. So not recommended. These are also snapshot. So I will go with 2.7.13. Okay, then provide the details here. So project metadata, the same thing that we had provided using Eclipse com.infi, and this I will name it as a demo Spring IOC. You can change the description accordingly, or you can retain the existing one. Package I will keep it as com.infi, and I'll not go with the higher version of JDK. or Java, I will choose 11, which is also installed, and my Eclipse also uses 11. So choose either 11 or 8. Okay, you can go with 17 also. There is no issues, but the best way is go with 11 or 8. 11 is recommended here. But it is going to work with 17 also. So what we did, let us quickly see that. So we have chosen the project as Maven, language Java, Spring Boot. I have chosen this 2.7.13 as stable version. Wherever you see snapshot, they are not stable one. Okay, they are in the initial phase. And then I have to provide the project metadata, group ID, the organization name. Artifact is anything you can provide. Okay, that name of the project will be same as the artifact ID, description of the project, and package name. Generally, we keep it same as the group ID. Packaging will choose it as jar. Here, choosing jar or var does not matter here, because we are not discussing at the packaging level, creating the binary and then deploying it. We will not be discussing at that level. But by default, it will take the packaging as jar. Means the final packaging of our project will be in the form of jar files, Java archive. So it's an archive file. Like we have exes and all, similarly we have jar files. And choose the appropriate Java version. Click on generate option. So it creates a Maven project for you. Basically, it's a Spring Boot project using Maven. I will extract this. So you see folder inside a folder. Take the folder that has all the files immediately inside it. Okay, so I will copy this and I will paste it inside my workspace. I will delete this one. Because both the names are same. It will take just 5 minutes to rewrite everything. So I will import that Maven project. So while importing, you have to go to the Maven option, choose existing Maven projects. Next, browse for it and take it to your Eclipse. So you see, this is taking the Java version that I have chosen. Other core modules, including Spring Beans, Spring Contest, Spring Boot, and all the basic support that is needed to create a Spring Boot application. So this solves everything. So I'm going to create a class with the name Spring Config. And this has to be annotated with add configuration. Before that, I will create the service class inside the package com.infi.service. Customer service IMPL. I think I just clicked on rename instead of doing refactor rename. That's why it has not changed anything here. And this is going to implement interface that does not exist, but we are going to create it inside the package service. And this interface will have, this is reverse engineering with the name add customer. And then we are going to return customer added. Going back to Spring Config, here I'm creating customer service IMPL. This is the name of the class. Don't get confused. This is the name of the method, customer service IMPL. Don't get confused. Here, C is lowercase. This is the method name. Generally, this is a best practice to keep the method name same as what you are returning, what type of object you are returning, so that it becomes easy to invoke them. Otherwise, we can use different objects also. There is no problem with that. And I will declare this as bean and provide the name as customer service. This is optional. Okay, this is optional. If you don't provide name attribute, then it will understand the bean with this name. If you provide bean attribute, then it will detect your bean with this name, customer service. Then going back to the main class, I'll remove the code which is already there. I have to create abstract application context object is equals to new annotation config application context, and here I need to provide the name of the configuration class, which is spring config.class. Then customer service IMPL, I will name it as service is equals to context.getBean. This will fetch me the name of the bean, which is customer service, and this needs typecasting. And in here, I will just include the call inside the print statement because it is returning a value. So when I execute this, it should display customer added. Okay, and it's a good practice to close the context also. The context that we have, application context object that we had opened here, at the end, you should close it. So if you see, the Spring Boot generates a logs all by itself. So this is a log where it started and then what it did. So this is a log that we understood yesterday, and Spring Boot has a default logging API that helps generating logs automatically. So it says it is creating an internal configuration from org.spring-config, then event listener processor, event listener factory, internal auto-wired annotation processor. So what all activity is happening at the backend, and then it is creating an instance of Spring Config, the configuration class that we created, and then finally it has accessed the singleton bean instance, which is customer service. Singleton bean instance means in Spring Boot application, for the entire application, it maintains only one object. It does not create multiple objects. What does it mean? For example, suppose I'm creating another object. Basically, logically or internally, it is not going to create a new object. It is not going to create a new object for the bean. To verify that, let us compare both service 1 and service 2. So if it returns true, that means both the references are pointing to the same object. If it returns false, if this comparison return false, this indicates that there are two separate objects. So as you can see here, it displays true. That means both are pointing to the same objects. So by default, in a Spring application, it uses only single objects and allows you to create only single objects throughout the application. So the benefit of this is any modifications that is happening will be happening only through one object. Okay, from wherever you are doing, only through one object, the modifications will happen, and that way it will become easier for anybody to get the details of the logs. Okay, how exactly the changes has happened, who has done the changes, when the changes has been done. Okay, but because if there are different objects and the changes are being done using different objects, it becomes slightly difficult to understand who has done which changes. Okay, so this is the flow. So we had created a configuration file inside utility package, where we had created a bean, okay, which is nothing but an object of the service IMPL class with a very simple implementation where the customer is being added. Here we will not, in this module, we will not go into detail about database and storage, because for that we will understand in a different module. In this module, we will understand only the service layer of the application. Like in Capstone project, the repository layer was provided to you. Okay, your focus was only on the business layer. So our focus here will be on the service layer of the application. So this is the service uh, layer, and then we have the client, you can say the client layer, from where the application context object is created. Then we are accessing the bean using context.getBean, and then using that bean reference, we are accessing the add customer method from the service layer. All right, I hope this is clear. You will find this demo in the course. There are exercises. There is one exercise on Spring IOC. You can do it post lunch. Basic code is given to you. You just need to go through with the content and understand what needs to be implemented. But it is going to be, you can refer this demo. You can refer this demo to do this exercise. All right, so shall we go with live quiz then before we proceed? Okay, please log into Springboard if you are not logged in. So you can take the link to the contest from the chat window. So this is the first one. So which of the following feature helps in developing a loosely coupled application in Spring? Those who are not able to join, you can watch my screen because that is something from the server end. I do not have any control on it. Okay, so we have the top three in the leaderboard. So the option first, POJO-based programming, dependency injection, and AOP. And if you remember, one of the feature of Spring framework is non-invasive, but here it is mentioned as invasive, which is wrong. Instead of invasive, it is non-invasive. There are two more questions. Let's go with the next one. Okay, so the leaderboard has changed now, and there are two options which are correct. Spring is an open source application development framework, and it is used to implement standalone application also. Okay, not just web. We can also design standalone application. And last two options are same. It is not mandatory. Okay, to include all Spring module jars for building any kind of application. We just include only those which are needed. Okay, here also we have included only those which are needed. There are many more dependencies. When we move further, you will see that there are many more dependencies which we will be adding. This will be by default added. These are the default one which is by default added when you are creating a Spring Boot application. Next one, you have to choose three options. So there is an online application that needs to be developed using data access layer. So what are the Spring modules that we can make use of? Data access layer is a layer which interacts with the database that has JDBC, ORM, right? So congratulations to all the winners. Professor Sudharani is the winner, then Professor Pampana, and then Professor Amanuttala. So only 2 points difference is there. So these are the correct option. Except test module, we need all other module because we don't need test module to connect to the database. Test module is needed only when we are testing an application. Okay, so test module is needed only when we are testing the application or writing the unit test cases. Okay, so let us proceed. We were not able to do one more live quiz yesterday. We'll do it little later. Okay. We'll continue with the concepts and then we will do that as well. Meanwhile, if somebody wants to know how we can use Spring test suite for Maven project, we can discuss it now. So Professor Ramesh, I guess you were asking about it. You can share your screen if the test suite is installed and available in your machine. I'm getting error like display prefix exception. How to avoid it? This could be some issues with the IDE. So you can give me the control. So STE IDE also, it also looks very much similar to Eclipse. Here also, whatever we do in Eclipse, we can do in Spring Suite also. It is just that it is designed by the Spring organization, Spring framework, for particularly for Spring building Spring applications. So here also we can go to File and choose New, or we can click this option, Create a Maven project. Use default workspace location. This option was same. Okay, here again, this option is also same here, right? So we just need to wait for the archetype to get loaded. So the archetype is loaded now. It takes some time. So org.apache.maven. And here we have chosen the default archetype, which is the Maven archetype quick start. So I will select that and click on next. So here it is almost same. com.infi, almost same, exactly same. Demo Spring IOC. A version will leave it the default one, leave it to the default one snapshot. It does not make any difference. Package com.infi and finish. So it downloads from the Maven central repository and creates a project for you. If you're doing it for the first time, if you have a look at the console, it is connecting to the Maven's central repository and downloading all the artifacts to create your project. Same thing that we did when we use Spring Initializer, the web-based UI, right? If you want, you can use Spring Tool Suite also, or Eclipse is also fine. If Eclipse, you're getting some error, that is because of the IDE. Just see if you have downloaded the Java IDE for enterprise developers. You should get Java IDE for enterprise developers. Okay, so you may stop sharing the screen. It will take some time and you will see the project gets created in the Package Explorer. So this is one time. This will not happen every time, whatever you see in console. This is the initial, because we are doing for the first time, so it downloads the initial dependencies and artifacts from central repository. So I've given you the control back. All right. So that is how we do in Spring Tool Suite. Rest of the steps are same. Yeah, you're welcome, Professor Ramesh. So then you can try this exercise. Will help you out in case you are stuck. You can refer the demo. Okay, because without doing this exercise, you will not get clarity on Spring IOC, what we had discussed. Next, we'll understand dependency injection. How we inject the dependencies, okay, to a bean. So if you have a look at this, what we understood here, what we did just now was we were creating a configuration class. There we had defined a bean. Okay, And then we have annotated that with @bean annotation, which was returning the object of service. Okay, so which is similar to creating an object for any class, right? So what dependency injection does is, okay, instead of developer creating these objects, okay, we just tell how these objects will be created. Okay, so there are two ways. One is using, so dependency injection is implemented in two ways. One is achieved through constructor injection, another is achieved through setter injection. Means we inject the dependencies either through constructor or we inject the dependencies either through setter, either with the setter methods. Okay, we can make use of setter methods also. So how do we inject these dependencies is what we will understand next. So first is using the constructor. Did we miss anything? This slide we had already discussed, right? Why Spring? If not, I will cover it with this. So what exactly dependency injection is and how it helps? Okay, that is what we need to explore now. So dependency injection helps us create a loosely coupled application, okay, by allowing the implementing class to create its own object. Okay, so what we will do is we will just pass the object instead of we defining hard coding the object creation. For example, if you see this piece of code, here we are creating the object of customer repository and we are creating this particular object. Suppose I want to create a different object for different repository. I can't do that because it is tightly coupled application. Okay, because you are straight away creating the object inside the class. What if there are multiple implementing classes? I cannot point to that one because you have hard coded the implementation. So this is tight coupling. Okay, you can't modify this. So how we can remove this dependency is instead of the class creating an object, the class will receive the object from the client environment for which the object needs to be created. Accordingly, it will create the object of that repository. Okay, so customer repository is an interface. Okay, customer repository is a class here. And then we are passing the object of this class here and we are initializing it here instead of creating it inside the class. So same thing dependency injection does. So it does it in two ways. One is using setter injection. Another is using constructor injection. So if you see the constructor injection, I'll straight away show you the code. So in constructor injection, what happens is the dependency is injected to the constructor. Means constructor, we will define a constructor using which the dependency is added or initialized through the constructor. This is same as creating a parameterized constructor inside a class and passing object to that parameterized constructor. Okay, passing object to that parameterized constructor. So it is exactly the same. I'll go to Eclipse. And we'll understand how the constructor injection is done. So what we will do is, we can make use of, I will create a copy of this, or I can create a new project by going to same Spring initializer, and we can create a new project. I will make use of, I will reuse this. Yeah, I will reuse this one. So what is missing, I will add that. So for constructor injection or setter injection, we don't need any other dependencies to be added in pom.xml file. The existing dependencies would be sufficient. Okay. So here we will be creating one more class, which is customer repository. Under the package com.infi.repository. Repository layer is the one that takes care of communicating with the database. Okay, this is the final layer of our application. This is the final layer in our MVC architecture. This I will define it as an interface. And this interface will be having public, the same implementation I will do. String add customer, and then inside this repository, I'm going to create a class customer repository IMPL. This is going to implement. This is how we do the implementation. First, we create an interface, and then we create the class that is going to implement that interface. So all those concepts that we discussed earlier, we are using it now. So now, whatever we were doing inside the service class, means returning this one, we will do it inside repository. Ideally, in real time, what will happen is it will receive the objects that we want to insert, and after insertion is successful, it returns a message that customer added successfully. But here we are not focusing on the repository part. We'll discuss it in the different course. So here our focus will be only on the service layer of the application. So this is the repository. Then inside the service, what we will do is we will create the reference to repository. Customer repository. IMPL. And just say repository. So we have created the object of repository, but we have not initialized it. This is pointing to null. Okay, this is just a reference that we had created. The initialization of this will be done through constructor. Okay, it will happen through constructor. And this add customer, what it will do is it will invoke the method of repository, which is add customer. We are keeping the name same. and this is returning a string, and that string we will receive it here and return it back to the caller. Earlier we were returning from the service. Now we have implemented one more layer which is the repository layer, and which is taking care of all the insertions. Assume that all the insertions are happening through repository layer, and then on successful insertion, it is returning back with a success message that we are capturing in the service layer and returning that message. So service layer is communicating with the repository. So this is customer service IMPL. The service layer will connect with the repository, call the appropriate method, and pass the object that we want to store. And it will return a message. Now we need to modify our Spring config now, because we are injecting the dependencies through constructor. So bean for customer service is already created. We will create one more bean here because we have a new layer now, which is the repository. So I will say public customer repository IMPL. So this is all about passing objects. So students are not clear about the objects. How do we pass it? And how do we call? How do we create? Then this will be confusing. Otherwise, this is a very simple concept. This is going to return new customer service. No, customer. This has to be uppercase. Return type would be customer repository IMPL. Now, inside this customer service, now if you see inside the customer service, now we have a constructor. So that's why it is showing an error here. And what the constructor is expecting, it is expecting the reference of customer repository IMPL. That means whenever we are creating the object of service class, we need to pass the reference of repository. So how do we do that? Return new customer service IMPL, and where we will get the reference of or where we will get the object of repository, we will get it by calling this method, right? Which is customer repository IMPL. So this is a function call or a method call. So this is a method call which is calling this method, which is returning the reference object of repository class, and it is receiving it here, and while in creating the object of service class, it is going to pass that reference here, and the initialization will happen accordingly. So now repository is also identified as a bean, which is managed by the Spring container. And this is the updated configuration class. Now everything is same. I mean, if you execute it, it will say customer added, okay, because there is no change in the client code. We are creating the abstract application context, creating a bean, and then getting the bean and creating a service. And using that, we are invoking add customer. What is the difference now? Instead of service class dealing with the details, dealing with the storage details of those customers, it is passing that responsibility to the repository layer. And repository layer, assume that it is connected to database, doing all the persistence, and after that it is returning a success message here. Okay, so which says customer added successfully. So now the flow is, so let us understand the flow again. This demo is available in the course, right? I'm just discussing how that demo works. So click on open. So this is the class client. This is the client or the class from where the call is initiated, and it is calling add customer. Okay, so add customer is inside the service class. Okay, add customer, from add customer it is going to the repository, okay, where the actual addition of the customer is happening. After that, the return is invoked. It is returning this message back to the service, which we are capturing here, and returning that message back to the main class, where we are displaying the details. Now, before it does all of it, it is creating an application context object, getting the details of the class where the configuration data is kept, okay, which is inside utility Spring Config, where the beans are created, okay, customer service bean and the bean for customer repository. So it is using that to get the details, and it is creating it is fetching that bean object from the Spring Config.class using the context object, and then we are able to access the service. So this is how it works. I hope this is clear. This is the only difference between the two demos that we discussed. So what is the difference? Now we are injecting the dependencies through the constructor. So if we have to inject the same dependencies through setter method, it is very simple. I just need to create a set method. Okay, so instead of constructor, now the dependencies will be injected through setter. Now, what do you think? What change is needed now? Where we need to do the change? Any other change that we need to do? Because now we are in doing the dependency injection by defining a setter. So no idea. Okay, no problem. So we have to do the changes in Spring Config only. Now here we are. Here earlier we were doing it through the constructor. Now we have to do it through setter method. Okay, so this bean will remain the same where we are creating the repository. Here we need to create the object of service is equals to new customer service IMPL, and then using that service class, we need to invoke the set method, and here I will call customer repository. Just using the setter method. And if you're doing using setter, then we need to change the config. In customer service IMPL, we are creating the object first, and we are setting the dependency using customer repository using the service class. Call the uh, set repository method of the service class and pass the object of repository. So in Spring config, we are doing exactly the same. We are calling the set repository method, and we are passing the object. So this is basically a function method call. It will call this method, which is returning the object of the repository, which we are passing it to the set repository method, and it is returning the service finally. Service object that has all the details. Okay, I hope this is clear. Then you have, so we have covered dependency injection as well. Constructor injection, you will find the demo here. Then there is an exercise on constructor injection. You have to do this exercise. You can refer the demo. It is easy. If you understood the demo, exercise is going to be easy. Then what is setter injection? We discussed how do we do that. And there is a demo also, the same demo that I just discussed, and the exercise on setter injection. Okay, I think we should stop here for today because this is something new and you should spend more time to explore this. Before we wind up, we will do a live quiz on concepts that we had learned yesterday. If you have any queries, please let me know. So tomorrow we will understand rest of the concepts, auto scanning, Spring Boot. Here it says Spring Boot. We have already started Spring Boot by creating this Spring Boot application. So the application that we created is Spring Boot only. And if you see the pom.xml, we have already included the Spring Boot starter module. We will learn more about Spring Boot starter tomorrow, what exactly this module is and what it comprises of. Then we'll understand auto wiring, Spring Boot logging, and aspect-oriented programming. Best practices and Spring profiles are something which you can explore. Followed by this, there is one capstone project. Okay, Spring 5 basics with Spring 5 basics transport domain. So you should complete this also because this will test your entire concepts that we had learned. And these remaining topics, they are very small topics, and we will be able to complete it tomorrow. It is not going to take too much of time. So let us go ahead with this quiz that we were not able to do it yesterday. So please join using the link that I'm going to share in the chat window. there was some problem. I'm sharing the link once again. Actually, I wanted to stop the timer because very less participants had joined. Use the new link from the chat window. Please connect to the live quiz once again using the new link that I have pasted in the chat window. Looks like there is some problem with this because I can see only 14 of you have joined. I will report it to the admin team to look into this issue. Why it is taking so much of time to join? Because in our internal application, people will join very quickly. It does not take much time. Yeah, because taking long time, sometimes if it is taking long time, that is some problem with the server. I'm sharing the link once again. Please use this link to join. The latest link that I had shared. I pasted one link just now. Use that link. So there is one certification called Spring Associate Developer. You can attempt this also. This is also available on Spring Boot. And apart from that, there is this whatever certification was mentioned by Girija, you can refer that. So let us start this. Um, Others can continue trying if you're able to join. Otherwise, we'll see. If you're not able to join, you can watch my screen. You have to identify the output of the code that is available on left hand side. Okay, so this was the code snippet, and this will be a compilation error because The show is final in parent class, and any method which is declared as final you cannot override. So that's why option C is right. Moving on to the next question. So here, first option is true. Interface can have static, default, and abstract methods. It is talking about the methods. Interface can have static, final, abstract methods. This option is wrong because we cannot have final methods in an interface. Interface can have only default and abstract method. That is wrong because we can also have static method. Interface can only have abstract. So obviously this is also wrong. When first one is true, all other options are wrong here. Next question. All right, so we have to choose the false option. There are two false options. Interface can extend from only one interface. This is wrong because it can extend from more than one interface. A class can extend multiple abstract classes. You know that a class can extend only one class, whether it is abstract or non-abstract, only one. Okay, moving on to the next question. I think we have two more except this. So you have to choose the correct about functional interfaces. So the correct option is, it specifies that the interface can only have only one abstract method. Okay, so this is the next one. Which of the following statements could be inserted at the comment line in this code so that it prints some error occurred? Okay, so there were multiple options. You have to choose two options here. So we can have array index out of bound exception. So this is a runtime exception. And null pointer is also a runtime exception. We cannot throw exception because runtime exception is a child of exception class. So runtime exception cannot handle a parent exception. And IO exception is a checked exception. It is not a runtime exception. So that's why option D is also not correct. Okay, final question. Identify the correct statement that can be placed in line 4 in the code below. So you have to choose two correct options. It's all about what all we can add to an array list. First of all, congratulations to all the winners. This time winners are different. And then the question. So we can either add a string or we can insert a null. Option B is wrong because we do not represent string using single quotes in Java. Option C is wrong because this is an array list of string and it will throw compilation error if you try to insert integer. That's why option A and D are correct options here. Okay, hope you enjoyed the contest and the session. Not sure about the session, how you have taken it. It was completely at the application level. Please practice all the hands-on exercises to get more clarity on this so that tomorrow when we discuss new topics on Spring Boot, it is easy for you to understand. Before we wind up this session, if you have any queries, please let me know. Yeah, I can understand some of you were not able to join. As I said, this could be a problem on the server side. I will just report this to the admin team. They will check if something can be done. Okay then, so thank you for joining today's session. We'll meet tomorrow again for the last session on Spring Boot of this week. See you tomorrow at 10. Thank you once again.